All right, welcome back. We're going to start looking at our algebraic methods of solving these systems of equations. So before we talked about doing them graphically, so changing things into slope-intercept form, graphing them, looking for those intersection points if there are any. So there's, again, three different types of scenarios you could have. There's one intersection point, the lines cross. There's no intersection points, they're parallel, or there's an infinite number of intersection points. So those are going to be your coincident lines. Before we take a look at things with variables and numbers, let's take a look at this situation. So it says in the following diagram, the cones have identical mass and the blocks have identical mass. How much does each object weigh? And find the strategy. So I essentially have two scales with different amounts of objects on the scales. Cones, blocks, and one big cylinder that I can see on there. It has a mass of 42 grams. So if I look at this second scale, it tells me that I have one cone, and that's the same thing as 3 of those blocks. Now you could double both sides of this equation and come up with the same ratio that 2 cones is equal to 6 blocks. Okay, so if one cone is 3 blocks, 2 cones has to be 6 blocks. Now, I do have, if I look back at the first scale, on the left side of that balance, I've got 2 cones. Okay, so by using that relationship that we built from the second weigh scale, I can see that 2 cones, those should be the same thing as 6 blocks. So I could really say that this side of this balance scale is equal to 7 blocks. Okay, this cone is going to be 3 blocks. This cone also 3 blocks. So in total, 3 plus 1 plus 3, that's going to be 7 in total. Now that should be equal to 42 grams. Now that means that 1 block, if I divide both sides by 7, that should give me 6. Okay, so a block is 6 grams. Okay, so that's kind of interesting. And we could figure that out basically not doing a whole lot. Now we've got to figure out how much those cones weigh. If I know that one of these blocks is equal to 6 grams, on this other weigh scale, I actually have 3 blocks stacked up. So if I say that one of the blocks is 6, the other one is 6, and the third one also 6, that means a cone should be equal to 18 grams. Okay, by not doing a whole lot of math, we could essentially figure out how much each thing weighs just by looking at the objects that we have. Now let's make sure we actually did this correctly. So I've got 2 cones here on the scale. So if I'm saying one of them is 18, if I add those 2 18s together, plus 6, the mass of this block that we're saying, I should get 42, and it looks like I do. So everything we did was correct. Now, we're not going to have cones and shapes all the time. We're going to have variables. So let's go put this and try this with some letters. So this method that we're going to talk about is called solving by substitution. Okay, it's an algebraic method of determining the solution to a system. We're working to isolate a variable, substitute it into the other equation, and then solving. So essentially, if I put that into words for this picture, we figured out how much one of those objects was. So we figured out that the block was equal to 6. Now, if I took that number, that 6, the amount of that block, I put it into the other scale. So I used that somewhere else to figure out what the remaining variable was. We're going to do the same thing, except relate that to x's and y's. So we're going to look at this system. Again, it's 2 equations, 2 variables, 2 different equations, and I have my variables of x and y. Okay, and we're going to verify that also. Now, a good piece of advice when you're trying to solve a system using substitution, one of those first steps is to isolate one of the equations, either 1 or 2. So again, we'll number them. Equation 1 and equation 2. A good piece of advice is to solve for a variable that doesn't have a coefficient, if possible. Okay, so the reason why is if I try to solve an equation that has a coefficient, I'm going to have to divide by that coefficient to get the variable by itself, which might introduce a fraction somewhere. It makes things a little bit not nice to deal with. But if you can solve for one that doesn't have a coefficient or has a coefficient of 1, the simplification is a little easier and there's no fraction to deal with. So I'm going to choose to work with equation 2 first. So we're going to solve equation 2 for x. Okay, there's going to be 3 steps here. So we're going to make kind of a chart. I just don't know how big the other sections have to be yet, so leave a little bit of room. So we're going to solve the second equation for x. So I'll write it in there first. X plus 2y being equal to 2. That means x is going to be negative 2y. Actually, I'm going to write 2 minus 2y. Okay. So there's an expression for x. So what we're going to do, always when you find that, you're going to take that expression for the variable and plug it into the other equation. So if I got that expression for x from equation 2, we're going to take that and we're going to put it into the other equation. We're going to put it into number 1. So I'll write it out first. 3x plus 4y is equal to negative 4. Now wherever you see x, you're going to replace it with the expression that you came up with. So x is no longer x. X is going to be equal to 2 minus 2y. Everything else stays the same. So plus 4y equals negative 4. Now notice what you just did. In this equation, there's no more x's. There's just y's. Okay, so now I've got one equation and one variable. So what we're going to do is distribute that 3 into the brackets, collect like terms, and we're going to figure out what y actually is. So this will be equal to 6 minus 6y plus 4y equals negative 4. So if I try to collect my variables together, we're going to have 6 minus 2y equals negative 4. Subtract 6 from both sides, and it will say negative 2y is equal to negative 10. Divide both sides by negative 2, and y is now equal to 5. Okay. So I've got part of this. Now, if it's a system of equations, we said that the answer has to be a pair of numbers. It'll always be a coordinate pair, x comma y. Now I know what y is, but now I have to go back in to find x. So the reason why this is called substitution is we're finding expressions and substituting them into different equations. So now I know what y is. We're going to have to substitute again into one of those two original equations. And it doesn't matter which one you put it into. Pick whatever one looks easier to deal with for you. So I'm going to take that value of y, substitute it into equation 2 now. Just because it looks a little bit nicer to me, both variables don't have coefficients. So x plus 2y is equal to 2. Value of y is now 5. So x plus 2, multiply it with 5, equals 2. X plus 10 is equal to 2. If you minus 10 from both sides, x is equal to negative 8. Okay? So now, by doing that, I know what my value of x is. I know what my value of y is. My solution looks like, so let's say the solution is negative 8, 5. Okay, there's my coordinate pair. The other thing we're going to have to do here is verify it. Now, by doing things algebraically, we might miss a negative sign, we might add wrong, we might multiply wrong, a whole bunch of things could happen. This is why the verification here is super important. And it's even more important to check both equations this time, because even though you solve one variable correctly, you could make an error solving for x, or you could make an error solving for y, and you won't know if you're right or wrong until you verify both. It was easier to do it with a graphical method because you can clearly see the picture and see where the point is. It seemed kind of pointless to verify it. Here it makes a big difference. Okay, so we'll go verify this. So verification. So we're going to check both equations. So equation 1 said it was 3x plus 4y equals negative 4. Place in those numbers that we think x and y are. So negative 8 plus 4 times 5 equals negative 4. So this will give me negative 24 plus a positive 20 should be equal to negative 4. So that one checks out. Okay, we'll check the other equation as well. So that one is x plus 2y is equal to 2. So negative 8 plus 2 times 5 is equal to 2. So negative 8 plus positive 10 should be equal to positive 2, and it looks like we're good. Okay, so we verified it, we double checked that our solution is right. We found all of the pieces. I find this little chart helps. There are always going to be 3 steps for substitution. Just picking one of your equations, finding a variable, substituting to the other one, and then substituting that answer into something else. Okay? Those steps will always be the same. Okay, we'll do another one down here. Now this one looks a bit different. The premise is the same. So number them off, 1 and 2. Pick an equation. Now I'm going to choose equation 2 because that y has a coefficient of 1. If you choose to do any of the other ones, it will work. Just remember that it might be a little bit more challenging because of the fractions. Okay, the answer isn't going to be any different. It might just be more work to find it. Okay, so I'm going to solve equation 2 for y. Let's make our chart again. Okay. So 4x plus y is equal to 5. That means y is equal to 5 minus 4x. Since I got that from the second equation, we're going to put it into the first equation. So y is now going to go in to equation 1. So equation 1 was 2x minus 4y equals 7. So that means 2x minus 5 minus 4x is equal to 7. Now this time, notice that if I'm plugging y in, that expression for y, I'm solving for x. It's always backwards. If I was plugging in x, I would be solving for y like the last one. Okay, we plugged in x, we got y. It's always opposite. Okay, so let's simplify. So 2x minus 20 plus 16x is equal to 7. So let's collect some like terms. I've got 18x's on the left side. That should be equal to 27. Hopefully I did everything correct so far. I'm gonna have a fraction, it looks like, which is fine. So if I divide both sides by 18, again, your calculator can help get that lowest terms fraction. So 27 divided by 18, 1.5 as a fraction, that's 3 over 2. Okay, so x is going to be equal to 3 over 2. So this one, fraction's kind of unavoidable here. Okay, now we've got to take x, plug it into a little bit, whichever equation looks easier. Again, I'm going to choose equation 2 because I only have one coefficient. So I'm going to take x, plug it into the second one. You can put it into the first one also, it won't make a difference. So that's 4x plus y equals 5. So 4 multiplied with 3 over 2 plus y equals 5. Now, if you forget how to deal with fractions, you're going to multiply numerators together and denominators together. So 4 is a fraction. It's 4 over 1. So 4 times 3 is 12. Underneath, it's 1 times 2, which is 2. So 12 over 2 should give me 6. So that's 6 plus y is equal to 5. Minus 6 minus 6, y is equal to negative 1. Okay, so there's my 2. There's my coordinate pair and my solution. So the solution is 3 over 2, negative 1 as my coordinate point, as my pair. Okay, we'll go verify it also. So here's our verification. Equation 1 first. So 2x minus 4y equals 7. 2 times 3 over 2 minus 4 times negative 1 should be 7. Now, for this first step, multiplying 2 with 3 halves, the 2's cancel, so it's just 3. That should be plus 4 is equal to 7. So 7 equals 7. First equation checks out. Second one is 4x plus y equals 5. So 4, 3 over 2 plus negative 1 equals 5. Now again, we already figured out before that this was equal to 6. So 12 over 2, that's 6, plus a negative 1. So that's a minus 1, should be equal to 5. And we can see that, yes, this solution does work, and it works in both equations, okay? Now, the third one is not a nice question at all. You've got fractions basically everywhere. Now, you could choose to work with them. You could also make them go away. It doesn't really make a difference how you do this, but it will work no matter what. Now, the second equation here is already solved for y. So what you could do is plug this expression right into that one and work just like we did before with the last two. However, I'm going to choose to show you how to get rid of these fractions just because it doesn't look very nice. Now, if you remember general form from before, you couldn't have fractions on anything. So you had to multiply your whole equation by the common denominator to make them go away. Let's do that here also. Now, just to make it a little easier, I'm going to still number them like before, but I'm going to choose to multiply the first equation by 6. Now, the reason why I'm choosing 6, if I look at the denominators here, they're 2 and 3. The common multiple between them is going to be 6, the first one that comes up. And you can find that quite easily by taking the 3 and the 2, multiplying them together, and that's 6. So we're going to multiply every term in here by 6. For the second equation, it'll be quite similar, and we're going to multiply all of them by, this time, 12. Okay, so what's going to happen is that the first equation will change to being 6 over 2x, which is 3, so 3x, 2 over 3 times 6. Now, if you're not sure how I'm doing this, I can go 2 over 3, multiply it by 6, and it gives me a 4. Okay, so plus 4y, that's equal to negative 6. So now you can see the fractions are gone. Bottom one, we're going to try to do this by multiplying everything by 12. So I'm going to have 12y's. Let's change that color. 12y's plus 3, or equals, sorry, 3x's. And 5 over 3 times 12. That 5 times 12 is going to be 60. Over 3 is 20, so minus 20. And let's just double check. 5 times 12. 60 divided by 3, and that gives me my 20. Now, if I tried to do this, which some people will try to do to get rid of those fractions, if I now look at this, I still don't really have an easy choice here. Okay, all of those variables do have coefficients, so in order to use substitution, I'm pretty much going to need to solve for one of them again and really simplify it. Now, I notice that those 3 x's are actually constant throughout. So let's make this purple one actually say 3x equals. Let's rearrange this. So we're going to say, we're going to try this, solve for 3x in the second equation. Now, the reason why I'm solving for 3x is I can see the exact same term in the first one. Okay, we're going to see if this works. Okay, so that purple equation was 12y equals 3x minus 20. If I solve for 3x, I'm going to add 20 to both sides. So that means that 12y plus 20 is equal to 3x. Now, what we're going to actually do this time, very similar, is we're going to take that 3x and we're going to put it into the first equation. So I didn't directly solve for x. I solved for a term that was exactly the same as it. And we're going to try plugging it in. Okay. So that equation that we had in black is the one we're going to use. So 3x plus 4y is equal to negative 6. Now we're going to replace our 3x with the expression we said it was equal to. So 12y plus 20. Okay. Plus 4y is equal to negative 6. Well, that shouldn't be 12x, that should be 12y. My mistake. Okay, so let's change that. 12y, it's still plus 20. Now it looks good. Now again, you can see we're plugging in something with x's and we're solving for something with y's. Collect like terms once more. So 16y plus 20 equals negative 6 minus 20 minus 20. 16y equals negative 6 minus 20. So negative 6 minus 20, getting more negative, so negative 26. Okay. So when I divide both by 16, I am going to still have a fraction as my answer. So let's divide that by 16, change it into a fraction, negative 13 over 8. Okay, so not a nice number at all, but still correct, still usable. So now I know what y is. So we're going to take that and plug it into one of these equations. Now, it doesn't really matter if you use the originals, if you use the ones you've altered. If you use the ones you've altered and you've altered them incorrectly, then this answer is wrong, which means if you substitute back into there, your next answer will be wrong. So we can try plugging it back into the originals to see what happens. So we're going to take y and plug it into number 2. Okay, we'll plug it into that original one, just purely by choice. Okay, so y equals 1 over 4x minus 5 over 3. So y is equal to negative 13 over 8, which means 1 over 4x minus 5 over 3 is the other side. Okay, and we've got to solve for x. So we've got to come up with a way to make this look really nice. Now, we can try to get rid of the fractions first, which might be a good thing to do if you're really uncomfortable with fractions. So again, we've got to find a common multiple between 8, 4, and 3. And I think 24 would be a good choice. So if we multiply everything by 24, we're going to be able to cancel out all these fractions. So we're going to multiply everything here by 24. And the reason why I know that, you could, okay, and see what that comes up with for you. Now 96 will also work. It is still a common multiple, but 3 is a factor of 24, 4 is a factor of 24, 8 is also a factor of 24. Okay, all of these will still work. If you want to do 96, the answer for x won't change either. So we'll multiply here. So if I do negative 13, multiply it with that 24, that's negative 312, but we have to divide it by 8 also, and I'm going to get negative 39. And so negative 39 equals 6x minus, I know it's 6x because I'm doing 24 times 1, 24 divided by 4 then. Gives me 6. Now, if I do 24 times 5 and divide that by 3, I'm going to get 40. So minus 40 on the end. Fractions are gone. Looks a bit nicer to deal with. So let's add 40 to both sides. Okay, that means that 1 is equal to 6x. So as a final number for x, 1 over 6 is equal to x. Okay, I've got my two numbers for x and y. So that means the solution is 1 over 6 and negative 13 over 8. There's my point of intersection. This is where these lines will cross. Now, it's not nice. It's decimal numbers. It's fractional, even negatives, but solution is still correct. Now, you can verify this one also. So I'm going to write out the verification steps. I should have enough room there. Maybe what I'll do is shrink this first. Okay. And then we'll verify it on the side. So verification. I can't spell. There we go. Number 1. That was 1/2 x plus 2/3 y equals negative 1. So we're going to try to do this with the originals, just to make sure we're totally right. So 1 over 2 times 1 over 6 plus 2/3 negative 13 over 8 equals negative 1. Now, if I multiply the first two together, I get 1 over 12. If I multiply the next two, 2 and 13 make 26. So that's going to be negative 26. 3 and 8, that's 24. That equals negative 1. I can't really add them together because I'd have different denominators. So I need to double the first fraction. So let's multiply everything there by 2. So that'll give me 2 over 24 minus 26 over 24. That should be equal to negative 1. 2 minus 26 is negative 24. That's still over 24. That needs to equal negative 1, which it does. Okay, so that one checks out. Now we've got to check the second one. Equation 2 is y equals 1 over 4x minus 5 over 3. Okay, our value of y was negative 13 over 8 equals 1 over 4. X is 1/6 minus 5 over 3. Okay. Now I can't do anything with the left, so we're going to leave that alone. I can multiply these two together. I'm going to get 1 over 24 minus 5/3. Now these aren't nice to actually put together, so let's grab our calculator. 1 over 24 minus 5/3. There's my decimal. Math 1 to change it. There's my fraction. So negative 13 over 8 equals negative 13 over 8. That checks out. Now you could actually do this, change this one. So I can actually show you that step here as well. So negative 13 over 8 equals 1 over 24. The common denominator here is going to be 24, so multiply top and bottom by 8. That'll be minus 40 over 24, which equals negative 39 over 24. And you can reduce that by dividing both by 3, and that equals your negative 13 over 8. Okay, so it does still work. There's a lot more work this time because of the fractions, but as long as you take your time, go slow through those steps, the answer will be the same. Now this is just one method. I know the answer key that you have in your notes does it a different way, but it still gets us to the same point. Okay, you could even do this with decimals. Okay, solve using substitution and verify. Now, like we got rid of the fractions before, we can get rid of the decimals here. Now, if you notice, each of those decimal places are in the decimals in the 10th place. So what we're going to do here is multiply everything by 10. And what that will do is move that decimal place to the right by 1 unit to make everything whole numbers again. So here's equation 1, here's equation 2. Equation 1 is going to change. It'll become 2x minus 4y is equal to 8. Equation 2 becomes 5x minus 3y is equal to 13. Okay, a lot easier to deal with. Now, we're going to pick an equation and choose a variable to solve for. Now, I'm going to pick equation 1 because I'm noticing that those coefficients are all even, which means if I go to divide something by 2, I'm going to cut them both in half and still have whole numbers. I won't get a fraction from the first one. If you try to use the second one, you're going to have to either divide something by 5 or divide something by 3, and that won't work out nicely. It'll still work mathematically, it's just more challenging because of the fractions. So we'll solve number 1 for x. Okay, so 2x minus 4y is equal to 8. That means 2x is equal to 4y plus 8, which means that x is equal to 2y plus 4. Let's fix, why is my eraser so large? Okay, 2y plus 4. Okay, since we got that from the first equation, we're going to plug it into the second equation. So x is now going to go into 2. So that was 5x minus 3y equals 13. So 5 times 2y plus 4 minus 3y equals 13. Distribute, collect your like terms, and then solve for your variable. So 10y plus 20 minus 3y equals 13. I realize I didn't budget my space right. Okay, so this means that 7y plus 20 equals 13. If you subtract 20 from both sides, 7y equals negative 7, so y is equal to negative 1. Okay. Now that I know what y is, plug it into one of those other equations. It doesn't really matter which one at this point, either 1 or 2, or even the original ones. I'm going to again pick 1. So y is going to go into 1. That says 2x minus 4y equals 8. Y is -1, so 2x minus 4 times -1 equals 8. So 2x plus 4 is equal to 8, which means 2x is equal to 4. X should be equal to 2. Okay, so now I know the solution is the point 2, -1. Okay, we can verify this as well. So verify equation 1, and we're always going to try to verify those original ones, even with the fractions or decimals, just to make sure that if we've altered it, that we catch our mistake. Okay, so 0.2 times x minus 0.4, multiply it with y, and that's going to be equal to 0.8. So we can grab our calculator, plug them in. 0.2 times 2 minus 0.4 times -1. That's equal to 0.8. Okay, so it does work. Check the second one also. So 0.5 times x minus 0.3, multiply it with y. That's equal to 1.3. So half doubled is 1. That'll be plus 0.3. So 1.3 equals 1.3. That one works out also. It's perfect. Okay, the last one on here will take care of a little bit of a problem-solving scenario. So create a linear system to model this situation. So you already invested $2,000, part at an annual interest rate at 8% and the rest at an annual interest rate of 10%. After 1 year, the total interest was $190. How much money did they invest at each rate? So there's 2 different accounts here. Now, the question in a systems of equation problem, the question pretty much tells you what your 2 things are going to be. So where it says how much money did they invest at each rate, that defines my variables for me. So let's use x and y. X and y. Now we have to actually come up with a definition. So there's 2 investment accounts with different interest rates. Okay, so let's say x is the amount invested at 8%, and you can switch those numbers if you want. X could be the 10% one for all I care. It doesn't really make a difference. For y, that'll be the amount invested at 10%. Okay. Now between those 2 amounts being invested in total, there was $2,000 invested. So my first equation is the sum of those 2 investments because it has to total $2,000. Okay. Now the interest rates are given to me as percentages. Now in order to use percentages like you learned in junior high, you have to divide them by 100 to actually turn them into the correct decimal. So 8% as a decimal is 0.08. 10% as a decimal is 0.1 if you divide by 100. Okay. So my second equation then is going to talk about the interest. So the 8% amount of interest earned from this account is going to be 0.8 multiplied by whatever's in there. So 0.08 multiplied by x. Same logic, 0.1 times y. In total, that's going to give me the interest amount, so $190. Okay. So there's my 2 equations, there's my system. Once it's set up, now it's solving it just like before. So the hardest part about an application question like this is actually solving for this, or setting up the system. But now we're still going to use substitution. So we're going to pick the equation that's easier to solve for a variable for us. I'm choosing equation 1. So we're going to solve, number 1, for, let's solve for y. You could solve for x if you want. Makes no difference. So x plus y equals 2,000. That means y is equal to 2,000 minus x. Okay, since we got that from number 1, we're putting it into number 2, always the other one. Okay, so 0.08 x plus 0.1 times y, which is 2,000 minus x, that should be equal to 190. So 0.08 x plus 2,000 times 0.1 is 200 minus 0.1x equals to 190. So now you're simplifying, collecting like terms just like normal. So 0.08 minus 0.1, that is negative 0.02x's minus 200 from both sides at the same time. Now 190 minus 200 gives you negative 10. Now you can divide by negative 0.02. So x equals 500. Okay, so now I know the amount that Yuri invested in that 8% account is $500. Okay, so now I'm going to need to go take x, plug it into another equation. Now you can pick either one. I'm going to choose number 1 again because it's the one that's a little bit easier to deal with. So x plus y needs to be 2,000. I know x is 500. That means y has to be 1,500 if you subtract 500 from both sides. In total, I had to have $2,000. Okay. Now you could verify it also and show that it works, but this means that Yuri invested $500 at 8% and $1,500 at 10%. So there you go. There it is, fully solved. I know you have the verification provided in your answer key. I'm just running out of space, so I won't do the verification for this one, but you're able to double check. So I hope that was okay. That's one of our algebraic methods to solve these systems. We're going to talk about the other algebraic method in our next video. See you next time.